So, welcome to Mr. Sweeney's AP Physics C class. Today we're going to be talking about universal gravitation. And we'll start off by saying gravitational force is the mutual force of attraction between particles of matter. Gravitational force depends on the distance between two masses. It acts on both objects equally. And it always acts from the point at the center of the object's mass and spreads out equally in all directions. We have the equation for universal gravitation, that is F of g equals g m1 m2 divided by r squared, where F is gravitational force, G is our gravitational constant, that's 6.67 times 10 to the negative 11 newtons meters squared per kilogram squared, that's in your reference tables. M1 and M2 are the masses of the two objects, and R is the distance between their centers. So gravitational force is a field force, meaning that it acts without any physical contact between the objects. All field forces follow the inverse square law. Let's talk about this inverse square law. This states that the magnitude of the gravitational force is proportional to the inverse of the distance squared. If the radius is doubled, the force is quartered. If the radius is halved, the force is increased by a factor of 4. So you invert the half, which is 2, squared is 4. If it's tripled, the radius is 1/9. So if it's times 3, you invert that to 1/3 squared. 1/3 squared is 1/9. Let's go over an example of universal gravitation. Now I want to know, what is the force of attraction between the moon and the Earth? First, some constants. The mass of the Earth is 5.98 times 10 to the 24 kilograms. Mass of the moon is 7.35 times 10 to the 22nd kilograms. The radius, or the distance between the Earth and the moon, is 3.84 times 10 to the 8 meters. And our gravitational constant is 6.67 times 10 to the negative 11 newtons meters squared per kilogram squared. And what I want to know is, what is our force of gravity? To find the force of gravity, we use this equation. Force of gravity equals mass 1 mass 2 divided by r squared times our gravitational constant. Plugging in our values from before, we have force of gravity equals 6.67 times 10 to the negative 11 newtons meters squared per kilogram squared, multiplied by 5.98 times 10 to the 24 kilograms, multiplied also by 7.35 times 10 to the 22nd kilograms. That's our gravitational constant, multiplied by the mass of both of our objects. We divide that by 3.84 times 10 to the 8 meters squared, and that yields us a gravitational attraction of 1.99 times 10 to the 20 newtons. We also have to take a look at gravitational fields. All objects with mass have a gravitational field around them which attracts other objects with mass. Gravitational field strength, or little g, is a gravitational force felt by an object a certain distance away from the object. And the units for gravitational field strength are newtons per meter, or newtons per meter, or meters per second squared. This should be not newtons per meter, it should be newtons per kilogram. Excuse me, please make that correction, newtons per kilogram. Our equation is G equals force of gravity divided by mass, where F is gravitational force, M is mass, and G is gravitational field strength. And let's do an example of this. At a certain location, a gravitational force with a magnitude of 250 newtons acts on a 50 kilogram astronaut. What is the magnitude of the gravitational field strength at this location? Well, we have our G equals F of G divided by mass. That's 250 newtons divided by 50 kilograms. And that gives us a gravitational field strength of 5 newtons per kilogram. And that'll be it for universal gravitation and field strength. Gravitation.